Just waiting for the recording. Okay. Protocols like the ARP, Address Resolution Protocol, or the DNS, Domain Name System, those are very famous network services, and they are tackled to reach, to intercept communicated medias, communicated data between clients and servers, and between, let's say, clients, requesters, and service providers. In this regard, so the success of those two methodologies, actually, they are clearly visible across the WW environment, the www environment. Whatever, this is sort of a question is for your reference only. The ARP caching, just let's continue from where we were able to stop last class. The ARP cache poison. We do not have actually ARP poisoning. We have ARP cache poisoning. It is a scenario which we might actually the role of the IRP, the ARP protocol, is to match in between the IP address, the IP address, and the MAC address. There have to be actually there have to be a match in between the IP address and the MAC address. Just give me a second, please. matching the IP address to a MAC address, and this means that the IP address is something that has to have a correlation with the physical address. The MAC address, as per the definition we saw last class, it is an address, yeah, MAC medium access control. It is an identifier that identifies the physical component, which is the computer, the server, the mobile, any digital device capable of being connected to the computer network. It has to have a MAC address. It is sort of a 128 bits address, 128 bits size numbering. It is an hexadecimal representation. The matching of this physical address to the IP address, the Internet Protocol address, is the role of the ARP, the role of this ARP protocol. Poisoning this ARP, it's to poison the cache where this ARP act. And poison the cache where this ARP act means an attacker would play the role of controlling the cache where the matching of IP addresses to this given, let's say, MAC address is, or this IP, so let's say this is the legitimate MAC address, this is the legitimate MAC address, and anybody tries to access and to open or to reach or to ask or to acquire the service through this MAC address, the attacker plays his role and tries to be faster enough than the server, which is the service provider, and replies the requester with a falsified MAC address, with a falsified MAC address. This falsified MAC address will lead to a different destination for sure. And the machine here, the client, if he receives, the first request, the first response received would be admitted automatically. The others would be rejected, whether this one or this one. This is the legitimate response. But if he receives first the response from the attacker, so he will admit this response. And thus, the ARP cache poisoning has been succeeded. The ARP cache poisoning. Cache, it's a sort of a memory. It means the cache, remember, we are talking about the volatile memory. It is a sort of a memory that resides in between the processor and the, let's say, the workspace somehow, in order to gain time when processing. So it is a memory, let's say, control. A behavior on top of a memory. The cache poisoning means the ARP cache poison means we are going to, or the attack is going to control the memory where the ARP is working, is processing. Can you just give me a definition, or not a definition, at least? Can you give me actually a comparison, a small comparison in between the ARP cache poison and the DNS cache poison? Are you able? It's a sort of a service difference, no more, no less. Good. Terminologies, we actually will go very fast. Still data, it's a sort of target, it's a name, it's a purpose behind of an attack. Still data, yeah. Intercepting only, simply just talking. When we do only the interception, we come back a little bit. Not here. Whatever. By just intercepting A, you send them messages or medias or whatever, share resources with B. Intercepting only is a sort of stealing. The sniffing, the static attack is a sort of stealing. So stealing the data, it's a purpose. By doing the interception. And the interception now, we have more than one mechanism how it would happen, the interception. DNS poison, DNS cache poison, cache poison. all of them mechanisms that can be actually utilized to intercept and steal data. McFlouden, it's a sort of actually an attack to flood the switch where the MAC addresses are recognized to be destinations. In the sense of we are going to bring the switch into a dead state to, let's say, either incapable to respond or to work as a hub, technically speaking. So here when you say the switch would be reverted into a hub, technically speaking means he will be able to, not he will be able actually, he will be خلاص hacked, and he will act as just a passerelle, just a gateway. Any message coming from any port will be exposed to everybody. The switch has the intellectual capability to be classified belong to the layer number 3 from the RSI model. Yeah, a hub is belong to the physical layer, which is the link layer, sorry, which is the layer number 2 from the RSI model. It only interconnects devices, that's it. A message sent from A, it would be received by all ports inside the hub. So the McFlouden, it would lead the attacker to make the switch act as a hub. Full stop. Context of filtering and utilizing the MAC address for security purposes, yes, is one of the contexts where, let's say, system admins, they may filter the let's say service delivery based on the MAC addresses. So an attacker might gain access and might have the chance to behave as a legitimate device. But when we talk about ARP cache poisoning, means there have to be a device recognized as a legitimate device with a falsified MAC address. So the context of the allowing or preventing the access to services, or let's say resources, or the internet itself can be controlled by falsifying MAC addresses. Falsifying MAC addresses. You have to understand it this way. Interceptions, it's a scenario of a man-in-the-middle attack. All of what we saw earlier, it is a sort of an interception, and then it is sort of a man-in-the-middle. The ARP poison here context, it is a very good example of man-in-the-middle attack. It's not the unique, but one of the very famous man-in-the-middle attacks. TCP hijacking is a scenario of yes, controlling the services delivered over the networks, the computer networks. TCP IP, it's a package of protocols, not only one protocol, via which you are delivering the medias, whatever, to be sent and to be communicated over the computer network. It has to be identified based on the TCP IP package. And when we talk about TCP IP, we are talking about a connection-based or connected mode communication. We are talking about transmission control protocol to be in action, and this transmission control protocol, it controls the layer number 3 services, which are mainly they are in connected mode. They are running in a connected on top of a computer network within a connected mode, let's say behavior, connected mode architecture. Great. The scenario of hijacking this TCP IP, it would help the attackers or the doers to falsify the communication in a sort of, because whenever we talk about media being sent over the network, the media will not be going or traveling simple bulk of data or just simple block of data. No, it will be segregated into packets and frames. Those packets and frames, they do have headers, and within those headers, they do have sequential order to arrive. Later on in a destination or a reception, they would be reordered and concatenated together to retrieve the original media. The sequential, let's say, order or counter, thing like that, it would be falsified. And thus you're talking about TCP IP hijacking. Because there might be issues in the internet or in the network layer preventing the packets or the frames to arrive in the same order. This is not an issue, because later on the destination, it would use the sequential order to rearrange the packets and the frames again and again until it gets the proper form. Yet hijacking, no, it will falsify this sequential order in a sort the destination will not succeed in ordering and retrieving the correct sequential order of the packets. Hijacking. Graphical preview of this context of hijacking. Good. The rogue access point is a scenario via which we gain access, or an attacker or a user gains access to, let's say, a private network using a wireless access point. The rogue access point is the access point the wireless access point that gives an access to strangers without being authenticated. There have to be no authentication. This is the graph that describes the rogue access point. The WOG access point. We have a private network, say in the University of Lisbon network, and we are having wireless access points in plural. And anybody tries to access the resources here, he has to pass through the filter to authenticate whether you are a legitimate user or not. If you are a legitimate user, you'll access. Not, you'll be blocked. Example of a filter: the firewall. The firewall. The firewall can play the role of, yes, you can get in, no, you are blocked, and so on. If a user gains access to the resources through a wireless access without being authenticated, so that access point is a rogue access point, and this is an attack that happened by this unrecognized user, non-legitimate user. So the rogue point is a weakness inside the network. The rogue point is a weakness in the network in a wireless mode, wirelessly seen, rogue access point. Scenarios via which we see attacks happening using wireless technologies. Every and each single service provider in a wireless mode, let's say the router or let's say your modem you use from your Mantella or from your Reader to get the access to the internet at home wirelessly. Actually, whenever you reach home, you check your mobile or you check your let's say wireless device, you see that there is a signal and your device has been detected. How? You did not do anything. You just arrived home. You just reached home. Your device immediately detects that there is a signal. What is that signal technically? That is due to the beaconing behavior done by the wireless device in your home, giving network access to home members. Your Omentel now or either the modem or the router used to give you access to the internet, it has to have the capability to beacon, not beaconing, to beacon, the verb. Beacon in the sense of us to distribute frames saying, hey, I'm alive. Hey, I'm alive. This way, it keeps sending again and again and again, and at time frames. Every 0.2 milliseconds, every 0.2 seconds, he has to send a frame distributed wirelessly saying, I'm available. Anyone wants to connect? I'm available. Anyone wants to connect this way. This frame, it identifies the device and the service to give the name, security, let's say authentication mechanism, and so on. This beaconing means the sending of those frames in a time manner. It would help the devices to recognize that there is a wireless network available. Okay. So, scanning for available beacons, scanning for available beacons, it is said word driving. It is word driving, literally speaking. وقت الحرب. So, scanning means searching. This is, you have to recognize that you are searching for what? Beacons. You are searching for the beacons, which are the frames sent and passed by the wireless devices, the wireless service providers. It is the word driver, because searching for wireless devices in a private area is illegitimate, non-legal. You get into University of, for example, Sultan Qaboos, and you are not a student from University of Sultan Qaboos. You are not a member from the Sultan Qaboos University, and you search for the wireless there. You are doing a word driving. You are not allowed to do so unless you have been given permission, or unless you ask for consent and you award yes the permission. Then after, you are not doing a word driving. But if you scan for beacons without asking in a private environment, you are illegally behaving, and this is against the law, the digital law. Word driving. Remember the word very well. Whatever actually scenarios via which we may do this word driver or succeed in doing the word driving, mainly you can use your mobile device simply, because using your mobile device you can scan for wireless networks. Okay, you go to Carrefour, or you go to any commercial services space, and you search for the public networks. Okay, what you are doing? You are doing word driving. If it is private area, you are doing word driving. If it's a public area, you are not doing word driving. But remember, let's say Grand Mall or whatever, there are private shops that they do not give free access. So by just displaying those lists of beacons from the private shops, you are doing a word driving. So you'll fall in all cases in a word driving scenario. Means you are doing a crime. Word driving, it's a crime. It's a digital crime. You have to be aware of that. Scanning for wireless networks is a crime. Is a digital crime. Remember, it is like that. Before doing the scanning for wireless networks, you have to ask for permission. Great. So I said technology that helps you to succeed in doing this word driving. Simply, you can say, we can talk about your mobile device. Simple. You have to understand what are the capabilities and the features available in your mobile device to say, yes, we can do the word driving or not. Because if I can ask you a laptop, can we utilize a laptop to do a word driving? You'll say, yes, we can. Why we can? Because we do have actually a wireless network interface, and we do have the capability to scan the wireless field. So the same features are available. We do have the hardware responsible for this sending and receiving wireless signals, and we do have the software responsible for displaying the list of the available, let's say, wireless networks. Another sort of a wireless signal, which is the Bluetooth. Remember here actually all the wireless signals responsible for carrying data, they are radio medias. They are radio only. All the, without exception, the wireless signals responsible for carrying data, they are radio waves. What does it mean? The Bluetooth is one of the very famous wireless signals, can be utilized through a mobile to send media from a mobile to another, for example. What is the Bluetooth? What is it? What is it in nature? What is it? It's a radio wave. It's a radio wave, but it is in a short range, to be utilized in a short range. 10 meters, 30 meters, 60 meters, not more than that. There are actually capabilities to enhance, and based on that, the range will be extended. But in all cases, it's a very short range to refer to. The radio wave defines all the wireless signals, but it can be utilized to carry media. Media means photos, text, audio, video, all the media we know. Great. Bluetooth can be utilized to generate a local area network. Yes, absolutely. Ad hoc network. Bluetooth can be utilized to generate a point-to-point network, a peer-to-peer network, an ad hoc network. Yes, absolutely yes. What's the problem? There is no problem so far. The technology here, it is available in between our hands and we can utilize. The problem comes here when we talk about Bluesnarfing. The Bluesnarfing is a sort of Bluetooth search, like we did for the word driving. We search for available wireless signals, available beacon frames. Here we are searching for available Bluetooth signals, those specific types of radio frequency waves. If you do so, you are doing a Bluesnarfing. The Bluesnarf is a scenario via which you search for the available Bluetooth connections. And since you do, you are not allowed to do. Actually, you are in a non-legitimate process. And the Bluesnarfer will lead. Actually, once you do search for available Bluetooth scenarios, will lead to yes, stealing the data, whatever, because we are not going to connect to Bluetooth for nothing. If you succeed in connecting over a Bluetooth device, means you are immediately inside the device and you steal the data inside, whatever the media is. Here actually we'll pass very fast. The scenario we define here is a scenario of techniques we use to hijack sessions. The session, what does it mean? Actually, whenever we open a computer or a device, we have to be authenticated in the sense of, okay, I'm showing you this slide. Who am I? Actually, it's not who am I the speaker, but who am I versus this device here to allow me share the resources here. My ID is available in front of you here. This ID is my session towards what? Towards the system I'm using. There are techniques available and described clearly in our book via which we may ask a resource without being authenticated. We are talking about null session. We ask a resource over the computer network without being authenticated. Systems do not deliver services to unauthorized parties. If there are services given to the public is recognized as public, is authenticated. But generally, systems do not give resources or access to resources to non-authenticated parties, members, users, subjects. Will not. But once happen, this is a null session attack. What does mean null session attack? It means accessing resources without being authenticated. It is not something that actually we can expect in nowadays operating systems because it is controlled, but the technique is recognized. If you access resources or services without being authenticated, you are doing a null session attack. Still, the techniques only of here, the access to resources only. It's a scenario via which this is actually a very particular case via which we are able to hack ticketing system that gives actually registration or reservations to flights, whatever. Domain name keying is a scenario via which we are hacking an available domain to deliver services to unauthorized parties. Yeah, because we said that it is a very particular system. So, any questions in this level, please? Any questions in this level, please? In this kitten, as I told you, it is a scenario via which we give access to, we allow unauthorized parties to use resources, no more, no less. Any questions in this regard the full network issues unit? Are you able to ask any questions, please?
No, Mr. Thank you.
If you hear your name, please say yes. If you hear your name, say yes. I'm going to open chapter number 5 meanwhile. All the issues we defined, all the techniques we defined in this unit chapter number 4 actually going to be secured in this unit number 5, which is the defenses. We are going to go through how to defend against those issues. So we saw vulnerabilities, we saw methodologies via which we apply those network attacks. Yeah, the defense now, the countermeasures. We'll define security measures to prevent those network attacks. Because when we talk about, for example, the DNS poisoning or the DNS cache poisoning, or let's say the ARP cache poisoning, what is the scenario to defend? Are we going to stop the use of the cache? We cannot. We cannot, because the cache is one of the security advancements set by engineers to facilitate and to make the process faster. So we cannot neglect it. We cannot block it. And if we set an let's say antivirus or a filter there to work on that filter, on that cache memory, we lose time. No, we cannot. There are other defense techniques that we have to pass through in order to protect against the network methodologies or network attacks we saw in chapter number 4.